Good afternoon, everyone. My name is Chrislyn Particka, and I'm the project manager of the Northern Grapes Project. Today's webinar is Developing Cold Hardy Grapes, the Trials and Tribulations of Breeding Grapes for the Northern Continental U.S. with Matthew Clark and Harlene Hatterman-Valenti. Matt is an assistant professor of grape breeding and enology at the University of Minnesota. His research focuses on using both traditional and molecular plant breeding approaches to develop improved grape cultivars for cold climate wine production. One key area of research is studying the genetics behind the resistance of common grapevine pests. Harlene is a professor of high-value crops and is chair of the Plant Sciences Department at North Dakota State University. She conducts research and outreach programs on cold hardy grapes and a number of other crops. Her work with the Northern Grapes Project focuses on vineyard management practices, although she also oversees the grape breeding project at North Dakota State University. Remember that as a participant in today's webinar, we ask that you please keep microphones muted if you have them. If you are having any technical difficulties, please type a note in the chat pod over on the right-hand side of the screen, and I'll do what I can to help. If you have questions, those get typed into the chat pod as well. We'll take a break in between the two presentations for questions for Matt, and then we'll have time at the end for questions for Harlene as well. So with that, Matt, I'm going to let you take over.
All right, good morning. Greetings from Minnesota, and thanks, Chrislyn, and thanks to the Northern Grapes Project for inviting me to come and speak today and see if I can make this work. So I just wanted to start off with a little bit about the history of grape breeding around the world and kind of bring you up to speed of where I'd like to take my project as we move into an area of using molecular markers for informing our breeding decisions. But I wanted to start with, over a century ago with this quote that I think still fits for today. And I'll just read it to you. There's a large field for the plant breeder to work in. We need hardier cherries and better varieties of plums for the market. We need long-keeping varieties of apples and many other fruits. And I guess I would say grapes here. So how do we get these? Only through the patient and hardworking plant breeder. And I think Harlene and I see a few other plant breeders in the audience today who would certainly agree with that. It takes quite a long time. And so hopefully you'll see as the presentation goes on today, you'll see where we can have an impact in using different technologies to either speed up the process of plant breeding or to make it more efficient in different ways. And just to show you that we've been having grape breeding going on at Minnesota as far back as the 1880s with Louis Swelter and Betta grape, and then with releases in the 1940s and then in the Common Era, which I'll talk a bit about as we go on. So a bit about the history of grape breeding in general. There were epidemics across Europe in the middle of the 19th century that scientists were really trying to figure out how to overcome, and primarily that diseases that they were interested in were things like powdery mildew. And at that time, scientists were able to access North American germplasm, so Vitis riparia and Cineraria and Rupestris and Labrusca and so forth. And we're noticing that those plant materials that they were bringing in offered some resistance. So at that time, these scientists and plant breeders started looking at ways to improve their crops by doing controlled crosses and looking for resistance. Well, in that process, they inadvertently brought phylloxera into Europe, which is an insect pest, which nearly devastated that entire industry as the insects spread across Europe. The advantage of the research that they were doing is that they were able to identify that the North American species weren't being infected, and so they were able to actually develop the technology of using rootstocks to revitalize that industry. And that's the same technology that is used today in most regions where Vitis vinifera are grown. They're using a North American species in the backgrounds for those rootstocks. So some other pests that they were breeding for and interested in include downy mildew and black rot. And as we look at this just short list of some of the pests that breeders were actively trying to overcome, these are the same key issues that we are interested in breeding for resistance to today. The great advantage that we have in North America is that we have somewhere between 22, 23 different species of grapevine that are native to this continent that we can turn to as plant breeders to incorporate and integrate traits that we're interested in. Across the northern tier, when we're thinking about our breeding program, we're keenly interested in cold hardiness. Here in Minnesota, we know that Vitis vinifera, or the European wine grape, will not survive here. Our winters are too cold, our growing seasons are too short, and so our breeders had to turn to native species like Vitis riparia, Vitis cinerea, and labrusca to incorporate that cold hardiness. And along with that came some positive things like disease resistance traits, but also some negative attributes like high acid, different flavor profiles, some good, some bad. And so even today, as a plant breeder, we're turning to the wild species to bring in unique traits. So here's a picture of John Toole. John is our vineyard manager at the University of Minnesota. And what John is showing here is what Minnesota winters can actually look like. John is standing on about 4 feet of snow. It's a nice drift going through his commercial vineyard in central Minnesota. Clear indication that Vitis vinifera won't be able to grow here. And when we think about breeding for cold climate regions like Minnesota or most of the Midwest, we have to think about cold tolerance. And that we mean, what are the low temperatures we're achieving in a winter? How many times we get there? What's the fluctuation from a warm temperature on a fall day to plummeting sometimes 50 or more degrees overnight, which can result in major injury to buds, canes, stems, especially as we're preparing those vines to go into winter. As we move across winter, something that we have to worry about even today is thinking about what happens if we have a spring frost and our vines have already pushed their buds out and all those preformed flower buds from the previous season are now susceptible to frost injury. So that's a major concern. And then as we move further into the season, we have to think about, do we have enough growing degree days? Do we have enough, a long enough season to actually ripen our fruit? And this is a critical concern for the germplasm that came out of the University of Minnesota with Vitis riparia in the background, is that we have really high acid levels in some of those varieties like Frontenac. And the longer that those fruit can hang on the vine, the more they can metabolize the malic acid and can produce a higher quality wine. So as we're thinking about winter hardiness and breeding for this region, we really have to think all year round about what's going on. In addition to winter hardiness, of course, we're also susceptible to all the same diseases and have those diseases prevalent in the Midwest as they do in other grape growing regions around the world. No breeding presentation on grapevine could go without mentioning Elmer Swenson. Elmer was a grape breeder who worked privately producing table grape varieties that were going to be hardy in the Midwest. Elmer was from Wisconsin and turned to Vitis riparia as well as French hybrids and other North American species to bring into his breeding program to really target a table grape for the upper Midwest. Elmer has had a very productive program, and we're still kicking around a number of his selections here at Minnesota, and other private breeders are interested in still evaluating that plant material and using it as a parent. He had the foresight to really get an industry developed here in Minnesota. So I'll just list a couple of the cultivars that Elmer developed, including St. Croix and St. Pepin, Swenson Red and White, Fabravois, and then Edelweiss was a joint release. So Elmer actually worked here at the University of Minnesota for a period of time, and that was kind of the introduction of Minnesota releasing the grape cultivars. They hadn't done so since the 1940s. At that time, in the late 1970s, some of the first crosses were made targeting wine cultivars, and we're actually in our 40th year with the Minnesota grape growers and commercial winemaking for this state. So we're a relatively young industry, and as you can see, the first wine grape wasn't released until 1996, and that was Frontenac. And since then, we've seen mutations of Frontenac, which is a noir grape, into Gris and also into Blanc. And the University of Minnesota has also released Marquette, which is a fine quality red wine, and La Crescent, which is an aromatic muscat type white variety. So here's a timeline to kind of show to you why Harrelson was saying we need to be relying on patient plant breeders to get a cultivar. So just to lay this out for you, this is a timeline spanning about 30 years. In year 0 is when we make a cross. And then in Minnesota, we actually grow our plants out in their first year into a nursery where there's a lot of disease and pest pressure. We dig out those plants. For their first winter, they actually live inside in a root cellar, which allows us to have better results and get more plants through the breeding program. But I guess I'll show you a couple more slides that look like this and talk a little bit more in detail about them. Ultimately, we don't really taste our first fruit until year 4 or 5, and we may not make the first wines until year 6, 7, or 8. And then ultimately, a cultivar might not come out until 15 years or more after that cross was made, which then means that the first wines might not be available for another 5 to 7 years. So this process is quite lengthy, as you can see. So here's a shorter version of the timeline. And again, I just wanted to point out that we start with year 0, and maybe by year 5, we've made some selections. And I'm trying to indicate that here by the size of the purple dots. So you can think about that we put out several thousand seedlings each year, represented by a big circle, or produce how many seeds as a big circle. And then in year 1, we see the circle's gotten a little bit smaller in the pest nursery. And then the circles get smaller as we move on. And that's because the breeder can make decisions as we go from year to year. As we move plant material basically out of the breeding program, those individuals get culled. And we see our biggest impact between years 1 and 2 after plants have gone through that high disease pressure. And then at year 4, excuse me, as those plants are fruiting for the first time. So when we think about what tools do we have available as plant breeders, we have to think about where can we change this timeline. One of the tools that we're looking to use are DNA markers. And a DNA marker is just a sequence of DNA, or maybe a sequence from a gene that can be used to identify an individual, represent a gene variant. And by that I mean, in grapevine, they're diploid organisms just like humans, in that every individual is getting one copy of a gene from its mother and one copy of the gene from its father. And in some cases, there's variation there. And we can use DNA markers to trace the inheritance of that through an entire pedigree. We can also use DNA markers to kind of act as a signpost along a strand of DNA, which allows us to do genetic mapping experiments. A genetic map looks something like this. This is where the state of the art was in 2009. This is some work coming out of Ann Fennell's lab. And what we're showing here are about 8 of the 19 excuse me, chromosomes in grape. And you can see that it's not a very dense map. We only have about 5 or 6 markers for every chromosome. So this can present challenges when we're trying to identify which markers might be linked to a trait. One of the major advances that have come out of the VitaShem project is the use of a different technology which allows us to saturate our maps with a lot more markers. And so on the left, what we're seeing, the far left, is showing chromosome 10, and you can see that we have nearly 100 markers now spanning that chromosome, and then similarly across all 19 of these chromosomes. So that gives us a higher resolution for when we do genetic mapping, which I'll talk about in a few slides. We can use DNA marker tests for a number of things. We can use it as paternity testing. Think Maury Povich, who's your daddy? We can go in and find out and trace the inheritance of traits and figure out relationships of inheritance. We can identify and validate the cultivar that we're looking at is true to type. But most importantly, we can use DNA markers to select our parents for crossing. Once we know which markers are linked to a trait, we can now make the determination of which parents to use based on their performance and having a trait of the marker of interest. And then as we move the breeding program along, we can also use markers to call our offspring at an earlier stage, basically predicting their performance at maturity when the plants are only in the greenhouse. As I mentioned, we can do gene mapping, which allows us to identify how a trait might be linked to a marker, and then develop a DNA test for that trait. And then ultimately, the goal is to identify which gene might underlie that. We're not quite at that stage because we don't have enough markers and large enough populations to do those experiments yet, at least at Minnesota. The term that we use to describe this work is marker-assisted breeding, and that's a kind of a catch-all term to talk about when we screen our parents or screen our seedlings. And the goal here is to accelerate the breeding timeline. But as you might see is that we're still probably going to end up in that 15 to 20-year range for cultivar development, but we're going to have different efficiencies of how we screen our material. So instead of screening maybe 100 plants that are varying in their performance at year 5, we can screen those plants in year 1 with DNA markers and maybe only move 25% of those into the field. So we're spending our time differently. And we can use marker-assisted breeding to gain insight and predict performance. This is just to show you where we can have those dramatic effects. The model on the top is where we're at today. But as we move forward, we can think about implementing markers where these blue arrows are and changing the dynamic. So you can see that we can have maybe start with larger seed sets, bigger populations, and at the end of 5 years, maybe have more plant material moving through the breeding program. So I'm going to just skip ahead quickly. As we've moved through DNA testing, we've identified that the cost of using DNA markers has really plummeted, and the cost for phenotyping has really increased. And by phenotyping, I mean measuring our traits of interest. So we need to be inventive and figure out ways to do these in a high throughput format. So using digital image analysis or machines to do the work for us. The key traits that are of interest in our breeding program are generally related to fruit quality trait. And fruit quality, in this case, we mean basically chemistry traits. pH, acids, what's the ratio of malic to tartaric acid? We know that the Riparia background brings in high amounts of acidity. We also need to target sugars so that we can make an appropriate amount of alcohol in our wine for stability reasons and for flavor and perception, but also flavors, aroma, and so forth. If we look at this figure, what I wanted to demonstrate is that our key region for looking at soluble solids, which are shown on the bottom axis, and titratable acidity on the left axis, we're trying to key in selecting individuals in the pink box. And as you can see, cultivars from Vitis vinifera fall nicely in there. But some of the Minnesota cultivars are outside of that. For example, Frontenac, which has about 15 grams per liter of acid and about 25% sugar, falls well outside that box. But if we look at its parent, we can see almost twice again how far Vitis riparia falls outside of our key region. So as a breeder, we need to start targeting more for this pink box and try to keep moving in that direction. And I'll just show you one more slide to show you when we start making selections in the field, we still kind of have a shotgun approach. And the problem here is that the plant breeder, when they're out in the field, tasting these samples, it's really hard to not get fatigued. Once you taste one high acid grape, it's really hard to start identifying where high acid and low acid and where high and low sugars fall. The mouth gets really tired really quickly, and in some cases, the fruit balance themselves out, and so that the breeder can identify that. So here's an opportunity if there was a tool available for us to measure titratable acidity in the field, we'd actually be able to maybe, one, save my teeth from erosion from these high acid grapes, but also allow us to target this pink box on and get rid of some of the shotgun that we're seeing that's missing our target. I'll just skip over that slide. I'm going to run out of time, so we're going to move to where we're doing some genetic mapping experiments. As I mentioned, powdery mildew has been a major problem for grape producers for centuries, and as we see in Minnesota, we wanted to know if we could identify any genetic resistance in some of our populations. This is some work that was conducted by Soon-Lee Tae, who's a graduate student at the University of Minnesota with Jim Luby. And Soon-Lee did some research and identified resistance in Minnesota germplasm to, at 2 regions in our genome to powdery mildew. So here's an opportunity for us to develop new molecular markers to screen seedlings in the greenhouse for resistance. Similarly, foliar phylloxera resistance has been mapped at the University of Minnesota as well using some field data. So this is some work that I did using data from 2012 where we had good phylloxera pressure in the field and identified 2 regions for resistance to this pest. This is really exciting for us because there's no literature about resistance to the foliar phase, and so this is the first report where we can start to think about developing technologies for screening for phylloxera resistance with our seedlings instead of waiting until those plants go out into the nursery. So that might allow us to skip the nursery step and move our plants directly out into the family row. And then a final approach that we're trying to use is digital image analysis to allow us a high throughput method. So can we train a computer to, once we have a digital image, to find a berry and analyze its color? And as a proof of concept, the answer is yes. And I'll show you the result in a moment. And can we train a computer to find a berry, determine its diameter, and give us an estimate of that berry size? And the answer here is also yes, but unfortunately the population that I worked with, all the berries were about the same size. And that's a challenge in doing a genetic mapping experiment that you need to have variation to accomplish that task. So berry color, like I said, as a proof of concept, we were able to use images to map 2 known genes, one on chromosome 2 and one on chromosome 18. So we were pretty excited about that. But more interesting, we've identified a new region in the grape genome on chromosome 6 that seems to be resulting in changes of anthocyanin, or those red colors that we're seeing in berries that are non-noir type. So this is a new opportunity for us to develop molecular markers for maybe pink-colored grapes. At the end of the day, and kind of at the end of Vitis Gen 1 project, we now have a lot of information across the grape genome where we have our developing marker test. And so this is kind of the map showing where we can start targeting different traits like acidity, sugar production, disease resistance traits, berry color, and phylloxera resistance. So we have a lot of tools now available to us in 2016 that weren't available in 2011 when that project started. So the question comes, what's next? Well, we need to develop our markers better. We need to test them across breeding programs and populations, and see if we can start determining if there's markers for flavors and aromas. And to come to the end of my portion of this talk, I just want to thank John and Jenny Toole, who manage our vineyard here, Brian Forbes, who's our winemaker. We have gotten a lot of funding over the last 5 years from the Northern Grapes Project and through Vitis Gen. And then, of course, I want to thank the previous leadership on this project, Dr. Jim Luby and Peter Hempstead, who without their expertise, we wouldn't be able to do the work that we're doing today.
Okay, thanks, Matt. We do have a few questions. David asked, do cold hardy cultivars have a different or larger temperature range for active photosynthesis?
Wow, that's a really good question. I'm not a physiologist, but I bet someone like Ann Fennell might know, or Jason Londo, who could maybe answer those questions.
Okay. All right. And then
I wish
David,
I knew.
I would assume that they probably would, but I don't know. It'd be interesting to maybe, I don't know if anybody's actually done any studies to, figure that out even. So anyway, then David also asked, if you own a trademark or a patent on a cultivar and it mutates, so like, the Frontenac Green, Frontenac Blanc, do you also own the trademark or patent on the mutation?
That is a good question also. I believe that's on a case-by-case basis based on the licensing agreement that is set up with our propagators and the producers themselves. So in some cases, like Frontenac Blanc, there's a number of those that are coming out, not from the University of Minnesota, but it's, I believe, again, that's a case-by-case basis and something that our Office of Commercial and, I never remember the name of it, would be able to answer that.
Leave it up to the patent attorneys.
Yeah, patent attorneys, our lawyers certainly know more than I do about that.
It gets pretty hairy, I know, so. Anyway, and then Tim Martinson asked if the Minnesota program has anything near release and what sorts of sensory attributes do they have. Before you answer that question, I'll mention that Drew Horton is on the webinar and posted a link to a presentation about MN125. But go ahead and talk about anything near release.
Sure. So we plan to release a white cultivar called MN1285. We do have a name for that, and we will be releasing that information in about a month's time. This is a white grape that should make a very fine, dry style white. The flavor profiles that I've only tasted it once. People have described something like Sauvignon Blanc, Old World Sauvignon Blanc. The data I can just point out, if I can go back in slides just quickly, it falls onto the table here, just outside of the pink box. The sugars are a little bit high, pushing about 25 bricks for us in 2015, but the TA, as you can see, falls into that nice range for winemaking, which is very different than many of the other cold hardy cultivars that we're growing.
Yeah, and just in case anybody's having trouble locating it, it's just above the R and the D in Chardonnay is where its little green box, little green triangle is for MN1285. So then Tim also asked if you guys have found a marker for perfect flowers as opposed to dioecious flowers.
That's a great question. We have markers from the literature that don't seem to work, and that's been a struggle in VitusGen because of the diverse germplasm that we're using with these different species. But we have developed a new technology. Shanshan Yang and Lance-Cale Davidson and Chi Sung out at Cornell have been working on a technology that we're calling amplicon sequencing, and that's a technology that looks like it's going to be favorable for identifying the hermaphrodite flowers in our breeding program, which in some crosses 50% end up being female, and that's not desirable for the breeding program or for a grower.
Okay, and then just to point out, Mark Hart, who is a private breeder and who actually did a webinar for us last year, got into a little bit more about the mutations in the patents. So I'll let you guys all read that since it's there for everybody to see, because we do have a couple more questions. Larry Robertson commented and asked the question, we are ripening cold hardy grapes in Montana better than our growing degree days would suggest. And he said that the Western Montana Experiment Station in Corvallis is looking into it. And he wonders if you have any ideas why, if it's anything with the intensity of the heat or the long days.
I would have a hunch that it could be both of those things. And by better ripening, I'm assuming that means that you are talking about the acids dropping out. So I would think that, excuse me, those longer, hotter days might be contributing dramatically to that, especially if photosynthesis isn't shutting down.
Yeah, and then Tim commented in the chat pod that it might be the amount of sunshine, and I would agree with that because he's done some specific comparisons between clusters that are shaded and clusters that are exposed, and the fruit chemistry differences, especially when you look at the difference in acidity, is pretty astounding. Mm-hmm. So it could just be that they get such high intense sunlight that they get better ripening. Then one last question from Keith. He asked what your favorite grape is.
That's a good question. I have a lot of interesting grapes that we have in the vineyard that haven't made their way into any commercialization. So I'm most excited about things that have labrusca in their background, but don't have the foxiness. So we're exploring things that taste like pineapple and strawberry and guava, things that most grape consumers have never tasted, and that gets me really excited about going to work every day.
Okay, one last question that came in because we still actually do have time.
Okay.
Kareem asked if you have studied the mutation that produced Frontenac Blanc and Frontenac Gris, and it wonders if it's a single point mutation, if you happen to know anything about it.
I don't. There's been some work done, and we think that it probably is the same type of mutation that's happening in Pinot, for example, but we haven't done any of that work.
Okay. All right, well, thanks, Matt. We really appreciate your presentation, and I am going to turn control of slides over to Harlene and let her get started. So, Harlene, thanks.
Okay, well, good afternoon or morning, depending on where you're at, I suppose. And I also want to go and say I'm very appreciative of this opportunity to kind of explain why we got involved with our breeding project and what we're trying to do and accomplish with this. Okay, like Matt, gotta make sure. Okay.
Hey, Harlene, we're having a little bit of trouble hearing you. Is your microphone close to your mouth?
It wasn't.
That's better. Much better. Thanks.
We started actually, North Dakota did have a great breeding program in the early 1900s. Somebody found a brochure that had an ND number on it, but that must have subsided quite a long time ago. We started our program in 2009 after our growers were having such a difficult time in keeping the plants alive, and nothing's more frustrating than to go and see one out of every 3 or 4 of your plants die completely to the ground, let alone all of them. Every other year or every third year. It just isn't a very profitable or feasible way of growing grapes. And so our goal is to develop one red and one white grape for primarily North Dakota. And the characteristics that these grapes have to have is they have to be hardy to -40 C or F at that range, so they're the same temperature, without any protection. And we say without any protection, meaning snow. On the eastern part of the state, we usually get quite a bit of snow, maybe not as much as what John was standing on in his vineyard, but some good protection and insulation for our grapes. But on the western part of the state, there rarely is very much snow, and so they don't receive any kind of insulation from that snow. We have to have them ripen early with, around 1,800 growing degree days on a base 50, which, if you look at the University of Minnesota grapes, I think with Marquette, the recommendation is about 2,500 growing degree days, so a much lower amount of heat. And of course, they have to be good quality. And having that Riparia base for this, our biggest challenge is going to be in the titratable acidity, as Matt alluded to. The Riparia have a good have a very high acid profile, and so we're looking at something at less than 1% or less than 10 grams per liter. So I wanted to show you, maybe justify what I meant by cold hardy. This is just the minimum air temperature for Fargo, and we have a wonderful weather station networking system, and so allowed me to go and take this from 2000 to just last month. And I put in the dates to kind of show you the winters, because looking upside vertical on some of those on the x-axis gets a little annoying. But anyway, as you can see, even in Fargo, every 3-4 years, here it's the 5th year. In 2003 and 2004, we got below -30 Fahrenheit. What is interesting is the winter of 2009, 2010, we also got below -30, but there we saw significant winter injury. So it's not, this tells you that it's not just the absolute low temperature that's going to go and cause dieback with your grapes. At our nursery near Minot, North Dakota, which is at the North Central Research Extension Center, you can see there's a similar trend as far as absolute coldness, but Minot will get some snow, but not always will they have early snow cover. And you can see actually that, now instead of having a -30, that we're getting down close to -40 in a few areas. And especially in 2008, 2009, where we didn't see anything like that in the Fargo area. As far as our growing degree days, I took the corn GDD model, which works out the same, and with NDON I can just plug in the dates. So I went from first part of May to the end of September for our growing season, and you can see that North Dakota does have a few, I don't know if I'd call them sweet spots, but you know, where we can almost get to that 2,500 growing degree days. But you know, when we get up to the northern part of the state, you can see why our goal was, you know, less than 1,800 growing degree days. So how are we going to accomplish this? Excellent question. We're looking at two approaches. The first is the short-term approach, you know, those quick hits, where we're crossing proven parents with elite material from our area. And this is the hope to go and get, you know, a releasable cultivar in one generation. And so the picture on your right shows a Riparia by Solaris cross that we've made, and at early veraison, the fruit cluster. But we can't just rely on that. We also want to go and use the long-term approach. More, I kind of put the analogy like building your house, in which we're trying to lay that foundation first before we start putting the boards on and going upward. And so we're making a series of crosses, the selections that to develop our parents. And so this is going to require multiple generations before we're going to have any releasable material. I'd like to emphasize that we need stability and quality early in this due to where we are. We have a continental climate, unlike Vitis vinifera, which is native to the Mediterranean area, where they have a slow decrease in temperature and then a slow warming of temperatures. We're just the opposite. We're in an area where we have very unpredictable conditions. Just this week, I guess, would be a good indication of what is happening in a continental climate. We went from, you know, highs at maybe 10 degrees, and 2 days later, we're in 60-degree weather. So it really can fluctuate, and that's probably not the most extreme temperature fluctuation that I've seen the 15-plus years that I've been in North Dakota. So North Dakota and probably many places is very similar, in which we'll have large temperature swings and an unpredictable growing season, in which you might have a very cool spring followed by a more typical summer, and then a short fall or no fall, and you're right into winter. Or it could be it's just very unpredictable. What we want out of our vines, I think, is what everyone wants out of a vine: predictable yields, quality, and incomes. And so this is what we're trying to accomplish by this. And by predictable, I do not mean like every other year or every third year. We need this on an annual basis. So our germplasm, as I mentioned earlier, is primarily from Riparia-based. We've used established parents from South Dakota and Dr. Peterson's program, where he introduced Valiant, which our studies have shown is one of our most cold hardiest cultivars to be grown in North Dakota. We're also using University of Minnesota's Riparias, and then we're also including a lot of our own Riparias from around the state and in Montana. It's it's amazing how, you know, you'll be at some meeting and someone will walk up, oh, you're the grape lady. I have this grape and you know that I on my property that's been there forever. And you know, those are the most wonderful opportunities because that's what we're looking for. We're looking for those riparian that, you know, they've been around for a good long time. They've seen, you know, that seasoned veteran that's seen everything and been there, done that, and doesn't succumb to, you know, those Indian summers where in the fall where you think you might go for a long time with mild conditions to have some kind of Arctic blast come through overnight and drop our temperature to way below freezing. And you can see there's many other contributors besides this. One other thing that we've incorporated, because we do have an extremely short growing season and, you know, not the, I guess I'd say, ability to go and have numerous crosses in the field, although we do go and do have field crosses, we just, you know, it's not as easy for us to be able to grow some of the plants that we need for crossing. So we've gone and adapted Tyler K-Band from the University of Saskatchewan, his greenhouse crossing, in which, you know, initially we had about over 100 varieties or cultivars that we had in the greenhouse in pots, and we'd go through the cold room, greenhouse, back to the cold room, and we were able to go and get 2 pollinations per year out of each vine. We had one plant that a couple years ago actually grew through the pot from the bottom and into the soil in the greenhouse that is in the picture, and it just took off. And that was something we were struggling with the greenhouse production was, you know, our vines were rather, I'd say, piddly. And so once we saw that how this vine took off once it got into, I guess, a more stable soil environment. You know, in any kind of pot, you can see that we tried to go to larger pots to try to have a more uniform and not such a fluctuation in water and like that. But it was still a struggle. And so once we saw that vine that it went through, we actually have gone and in the last 2 years completely changed over to trying to grow these plants in the greenhouse, in the ground, and now we're able to go and have multiple stems on a single plant that has various stages of development for fruit. As you can see in this picture, we have a Limburger. In the upper corner is a cluster that is just forming, not quite ready for emasculation. We made a cross March 1st on this. We made an earlier cross in December. There's a ripe cluster you can see there. There's other clusters that are in various stages. And so with one vine, we're able to go and have a multitude of crosses. Now, there are advantages and disadvantages of going to having these plants in the ground versus in pots. And primarily the differences are insects and diseases. When you have that plant growing there the whole time, it's much more difficult to control some of the insects and diseases. Then if you, for example, powdery mildew, you're using a sulfur burner, you might have some cultivars or some plants that are extremely sensitive to sulfur. So, you know, it isn't that panacea that, you know, eureka, we found the answer to everything. But it does go and I think give us a lot more opportunity to do a lot more crosses than we were seeing with having the pots that we would put into the cooler and manipulate that way. The last little part, I'm just going to go through and kind of just show the rest of our process. Of course, once you get your seeds, you have to go and do some manipulation so that you can promote germination. And you can see with these 3 vials, not all clusters are as fruitful as others, and so you might go from just a few seeds to quite a few seeds. From this, then we would go and we'd put them in little containers and try to promote germination. And you can see in this vermiculite, there's a few seeds that are starting to germinate. The next step would be from there to put them into containers or cones and in the greenhouse to grow to the stage when we can then, after this, bring them out into the field, or not into the field, just bring them outside, acclimate them to the outside, and then plant into our nursery. This nursery is the one we initiated up at the North Central Research Extension Center, and it was started 2 years ago, and on the 3rd year, and now we're already running out of space. And so it doesn't take too long when you're planting several thousand seedlings every year to go and run out of space. The next couple slides, I just want to show some of the variations that you get with a single cross. And so here's Regant with the South Dakota Riparia, and just in the leaf morphology, you can see how different you can go and get with these leaves. Likewise, each cardboard is a single cross, and the plants, or the fruit from those seedlings that we planted, and you can see how different the cluster size can be depending on each individual. A little bit more of a close-up of this showing a single cross and the fruit prior to veraison, something that you can go from a very loose cluster to a very tight cluster. So I show this picture. This is 2009, our wonderful flood that happened because of the Red River. What else can be done to help growers? Well, I really think a lot can be done. What we're trying to focus on is, winter hardiness. And we know that what we need is that plant to shut down in early fall, regardless of what kind of environmental cues it's receiving. And the Riparia is good for that. It's more sensitive to day length than to air temperature and soil moisture in starting that acclimation process. And so by having something that isn't fooled by Mother Nature is going to help us because we just can't have a plant wanting to continue to grow like the Vitis vinifera would if we had conducive weather conditions. And so likewise, we want to start to investigate. Jason Londo indicated that the Riparia from around the Texas area would go and break bud for him much later. So if we incorporated Riparia that also broke bud later and went into a very determined, stable dormancy, we're trying to go and help on both ends. So I think there's lots that can be done to help growers. Oh, come on. Sorry, trying to advance. Okay, there I go. Now this couldn't be done by one person alone, and actually, I'd say John Stanger, who is a PhD candidate and just finishing up, has been, and I've always said, has been the backbone to this. He's an extremely hardworking, knowledgeable person. Right up there would be Colin Allwater, but I guess for a project like this, it takes a village, and you can see all the people that have helped, and we are extremely appreciative. Many of those private breeders gave us seed in the beginning because we had nothing to go with, and have been so helpful in so many ways, and just I guess working with a lot of the growers and like that, it's just been tremendous. We may not have that water by the side, but, sometimes that isn't bad either. So with that, I think I am at the end, and I will take any questions.
All right. Thanks, Harlene. We had a couple come in. Let me pull those up real quick. Patrick asked, one of the least researched aspects of plant cold hardiness is the hardiness, or lack thereof, of the root system. Do you anticipate that root hardiness may prove to be important in your work, particularly in light of the lack of snow cover in much of your state? And do you anticipate developing a protocol for root hardiness evaluation?
Well, that's an excellent question. It really hasn't been researched enough to go and say, for example, with Marquette, is it because of root hardiness? We have just as much damage because of when we have plenty of snow cover and cold temperatures as when we don't. But, it is something that should be examined, and in the future I would like to, but I don't think that is necessarily our biggest problem. I think our biggest problem is the fact that our plants are not dormant early enough when we go and get some of these Arctic blasts. And John has done some research and looking at various cultivars, and he has shown that some of these, if you give them good weather, air temperatures, and soil moisture, they will try to continue to keep on growing, just like your Vitis vinifera. But there's some others that they receive that day length cue, and regardless if you give them temperatures that are conducive to continue to photosynthesize, they will start to acclimate and go into their dormancy. So I don't think it's necessarily the total cold hardiness. Soil is a very good insulator too. But, I think our biggest problem is because our plants are not becoming dormant early enough. Long answer to something that probably could have been answered much succinctly.
No, that was interesting. And then Matt actually asked, what are your lighting requirements or the day length for the multi-season greenhouse crossing program that you're using?
Okay, excellent question. In the greenhouse, we have the lights on for 16 hours of day length, and even though we have those plants in the ground and are using them year round, we still see that we have they aren't as productive in the winter versus spring, summer, and fall, and so we're trying to address that. We're going to see if it's just that we don't have enough light intensity, not that it isn't the length, it's the intensity of our light.
Okay. With that, that's all the questions. So I would like to thank Harlene and Matt again for excellent presentations. It was all very interesting. And thank you to everybody out there who asked questions and who provided more information via the chat pod. It's always great to get a good conversation through the chat pod. So thanks, everybody. With that, I do have a few announcements to make. First off, I ask everybody to please take our end of project survey if you haven't already. The Northern Grapes project will be ending in August, the very end of August this year. And we do need to have input from our industry members about so that we can evaluate how the industry has grown and changed since the Northern Grapes Project started, and use it for reporting both back to the industry and then to the USDA. So please take our survey if you haven't already. I posted a link to that in the chat pod. I will warn you that you probably will want to have some records on hand to take the survey, and it will take you approximately a half an hour to take the survey. If you haven't gotten a link to the survey via email, feel free to email me and I can send it to you directly. The survey is probably going to be only open for a few more days, so this is something that we ask that you please do soon. So one more slide with the 2 webinars that we have left for this 2016 season. The one next month is in April. It's with Patty McManus and Carl Rosen, 2 members of our project team. Patty is going to be talking about some of the fungicide sensitivity work that she has been doing as part of the Northern Grapes Project, and Carl is talking about the vine nutrition work that he has done. Then in May, we'll have Ann Fennell and Adrian Hegman and Sumshai Rice, who are going to be talking about some of the work they're doing, looking at the flavors and aromas that are in the cold hardy grapes and wine. So with that, thanks again, everyone. Harlene and Matt, thanks, and our audience, thanks. Good seeing all of you.